Hi, my name is Hannah Banyan. I got assigned problem number 3, which is section 4.314 on page 296. So the instructions for this set of problems says use partial fractions to find the inverse Laplace transforms of the function, because there's only one here. So the function for number 14 is f of s equals 5s minus 4 over s to the third minus s squared minus 2s. So the first thing I did to kind of try and simplify it down into forms of Laplace transforms that we know is I pulled an s out. So then f of s is equal to 5s minus 4 over s, and then s squared minus s minus 2. And this here we can easily pull out into factorable form. So we get 5s minus 4 over s. And here we can see that we can split it up into s plus 1 and s minus 2. And if we factor, or if we multiply this here, we'll just get this right there. So next, because we still don't have this here in Laplace transforms that we know, so then I went ahead and I did partial fractions. So I got it into the form of 5s minus 4 equals a over s plus b over s plus 1 plus c over s minus 2. And you can just see that I split up these into the partial fractions down here. So next I went through and I forgot to do this is over s times s plus 1 times s minus 2. So then I went ahead and I multiplied this onto this whole side, everything over here. And so that's 5s minus 4 equals a, and then the s here and here are going to cancel, so you're just going to be left with s plus 1 times s minus 2 plus b times, so here the s plus 1s are going to cancel, so you're going to have b times s minus 2 plus c, and here the s minus 2 and s minus 2 are going to cancel, so you're going to be left with s and s plus 1. So then I went ahead and I said if s equals 0, so then this term will be 0, this term will be 0, so we'll be left with 5 minus, this is 0, so we'll be left with negative 4 is equal to a times 1 times negative 2, so we're left with negative 4 equals negative 2a, and if we divide negative 4 by negative 2, we get 2 equals a. So that's our a term. And now if we solve for, let's solve for b. So in order for b to be 0, let's solve for c. So in order for c to be 0, we need to set s equal to 2 to cancel out the a and b terms. So if s is equal to 2, then 2 times 5 is 10 minus 4, which is 6, is equal to, so this is 0, this is 0, so then c is 2, c will be 2 times 2 plus 1, which is 3. So 6 is equal to 6c, so that's just 1 is equal to c. So next, if we want to solve for b, we have to cancel out the a term and the c term, and so in order to do that, we have to set s equal to -1. So if s equals -1, then we have -1 times 5 is -5 minus -4 is -9 is equal to, and then we have this is 0, and then b, so b times -1 times -1 minus -2, which is -3. And then this will be 0. So then we have -9 is equal to 3b. So then we just have -3 equals b. So now we have all of these values, so we can go ahead and plug that back into this whole equation. So our new f of s equation will be f of s is equal to a, which is 2 over s, then b is -3 over s plus 1 plus 1 over s minus 2. And now here we can see that we know how to solve all of these Laplace transforms, so I'm just going to take the L to the -1 of this whole entire thing here. So that gets us f of t is equal to, well, we can pull out the 2, so we have it in 1 over s because we know how to solve that. So 2 times L to the -1 of 1 over s. And you can pull out the 3 here too. Minus 3 times L to the -1 of 1 over s plus 1 plus L to the -1 of 1 over s minus 2. So we know this right here. We know that 1 over s is just 1. So now we have f of t is equal to 2, because this is 1, and then times 2, so we have 2. And then this right here, we can get it into a form so that we can put it as e to the at. So if we take that and we pull out a negative sign, we have negative here, and we can make this negative. So then we have s minus 1. And then, we'll have s, so this, minus 3. And if we look in our table of Laplace transforms, we can see that this is the form of e to the at, and a is 1. So it is e to the -t. Oh, I did not mean to do that. So I'm going to just erase that part right there, and I'm going to rewrite it and explain it really quick. So if we have s plus 1, if we look in the table of Laplace transforms, the form is 1 over s minus 1. So if we have a be -t, then that's into the form that we want it to be, not pulling out the negative, because then obviously that would have made the s negative, and we don't want that. So my bad. I hope I cleared that up. And so then we have plus this guy right here, and that's already in the form of e to the -at. So it's just, e to the at, so it's just e, and then a is 2, so e to the 2t. So if we go ahead and write that in full, we have f of t is equal to 2 minus 3 e to the -t plus e to the 2t. So that is our answer into the inverse Laplace transforms using partial fractions.